Hey there, so I wanted to go a little bit more over these jigsaw puzzle problems that we've done and just talk about how they connect to some of the ideas we've been using with sequences. So first we'll start with this little 3x3 puzzle, and we're going to call this puzzle number one. So this is like the first term, because I can't really go like much smaller than that. Um, I guess I could do a 2x2 puzzle, but that one gets a little weird. So we're going to call this the first puzzle. And if I start going through and thinking about the different types of pieces, there's a middle piece, there are these four edge pieces, then there are these four corner pieces, right? So using our like sequence notation, I could write that like this. I could say that on puzzle number one, the number of C pieces, the number of corner pieces, is 4. The number of middle pieces on puzzle number one is 1. And the number of edge pieces on puzzle number one is 4. And then we can look at the next size up. So if we go the next size up, we're going to make it into a 4x4 square. If you look at that, now our numbers, have a different thing. We're talking about puzzle number 2. For this one sec. All right, there's always interruptions. Students desperately needed a bouncy ball. So anyway, I was saying here on puzzle number 2, we have different numbers. We've got now 4 corner pieces. We've got 4 middle pieces. But we have 1, 2, 3, 4, 5, 6, 7, 8 edge pieces. There we go. Come on, pen. 8 edge pieces. So I could say C2 is 4. M2 is 4. E2 is 8. Okay? Let's draw out one more of these puppies here. And then we're going to try to see if we can figure out a pattern that kind of extends. So there's 1. Alright, so I think I drew that. It should be 5x5. Yep, 5x5. Okay. So on puzzle number 3, I think it's kind of obvious that there's still only 4 corner pieces, right? There's still only these 4 corner pieces. Now I'm not going to count them one by one for the edge pieces. I'm going to count them in groups. I can see that there's one group of 3, 2 groups of 3. Here, let's use a different color. One group of 3 for the edges, another group of 3 for the edges, another group of 3 for the edges, and another group of 3 for the edges. So for the number of edge pieces here on puzzle number 3, I have 4 groups of 3. 4 times 3, I've got 12. 12 edge pieces. And then if I look at the middle pieces, again, I'm not going to count them all one by one, but I can see that there's one group of 3, another group of 3, and another group of 3 like that. And so the number of middle pieces on puzzle number 3 turns out to be 9. So then we can start thinking about these as sequences. What we can hopefully do is predict the corner one pretty easily. Would we agree that the corners is always going to be 4, no matter how big of a puzzle I make? The way that I can tell you that the corner piece is always 4, no matter what size we're at, is to write down this statement. So I'm going to put a little box here. These are for our generalizations. So when I say generalize, it just means instead of talking about a specific case, like saying this is the first puzzle, the second puzzle, the third puzzle, we're saying what's true in general, what's true for all the different cases. So what I'm saying is that no matter how big my puzzle is, so for any letter N, or for any letter X, I've got 4 corners. It just stays the same, 4, 4, 4, 4, 4 the whole way through. When we look at the edge pieces, you might have noticed that the edge pieces are always going up by 4. So one way to say that is that the edge pieces for pattern number N, whatever pattern you're sitting at, is however many you had before that plus 4 more. Okay? So I want you to notice, if I go back and look at, say, E2, 8 is the same as E1 plus 4 more. And if I look at E3, 12 is the same as E2 plus 8. So each time, what I'm noticing is that E2 is E1 plus 4, E3 is E2 plus 4, E4, if I drew it all out, would just be E3 plus 4. So if we just kind of extend that process down, we end up with this formula right here. Okay? That's an example of an arithmetic because it's adding the same amount every time. So arithmetic. The last one, the middle pieces, that one grows in a different pattern. We have a 1 by 1 square in the middle for pattern number 1. Then we have a 2 by 2 square in the middle for pattern number 2. Then we have a 3 by 3 square for pattern number 3. So the number of middle pieces for pattern number n is just an n by n square, n squared. All right. So there's lots more that we could do with this. We could start looking at rectangles. We could start looking at other things. But I just wanted to show you some of the generalizations and use our sequence notation for it. All right, let me know what questions you have. Thanks for watching.